In the mid-30s in Great Britain, work was in full swing on a new series of twin-engine medium and heavy day and night bombers for the Royal Air Force. That series included Armstrong Whitworth Whitley, Handley Page Hampton, Bristol Blenheim, and Vickers Wellington. All of these aircraft later played important roles in bomber command operations during the first months of the Second World War. But progress in aviation was occurring so rapidly that the Air Staff was forced to pay attention to the need to create yet another series of new designs. A little over 3 years remained until the war. At that time, in 1936, it was not yet certain that the Third Reich would become a potential adversary. Only at the end of the year did it become clear that the negotiations in Geneva would not lead to restrictions on the size of bombers or on their numbers within the air forces of different countries. In fact, no agreement was reached at the negotiations regarding either quantitative or qualitative restrictions. Nevertheless, the Air Staff prudently guarded against the possible consequences of such restrictions. 3 new bombers that were then being prepared for production were designed with a predicted empty weight limit in mind, yet they had dimensions that would easily allow them to take advantage of any relaxation of that limit, which later indeed happened. The new single-engine bomber accepted for production, the Fairey Battle, had characteristics that fully satisfied the anticipated weight restrictions, although it did not provide a substantial improvement compared with existing types. The Air Staff then turned its attention to new heavy bombers that could give British aviation the ability to deliver a powerful strike far from England, even if the total number of aircraft were limited by an international agreement. That foresight by the Air Staff in 1936 led to the preparation of specifications for 2 new bombers. Thus began developments that had far-reaching consequences and enabled Bomber Command to perform its duty in the Second World War. Those 2 specifications directly resulted in the production of the Short Stirling and the Avro 679 Manchester. Even more importantly, they also set the stage for the emergence of the Handley Page Halifax and the Avro Lancaster, the 2 most successful heavy bombers of the Second World War. It was with these machines that Bomber Command was able to conduct a strategic aerial offensive against Germany with devastating effect. While one specification concerned only a heavy bomber, the other envisaged a broader spectrum of combat tasks, but with a smaller bomb load, 8,000 pounds versus 14,000 pounds. Both types were required to have sufficient fuel capacity to fly 3,000 miles, but only the second specification demanded internal carriage of an 18-inch torpedo in addition to a certain quantity of bombs. This condition determined the size of the bomb bay and later allowed aircraft developed from that specification to carry the largest bombs of the time, whereas aircraft from the other specification with smaller fuselage bomb bays and additional wing bays did not have that capability. For the Air Ministry was already clear, even before the specifications reached industry, that any aircraft meeting those requirements would be larger and heavier than any machines then in service. At the same time, various dimensional limits had to be taken into account. The wingspan, for example, could not exceed 100 feet. Otherwise, the aircraft would not fit into existing hangars. The design had to be composed of parts that could be transported by available transport in case of replacement. Far more important, but rarely mentioned, the limitation for the bombers of 1936 was connected to the size and strength of contemporary military airfields. None of them had runways capable of withstanding an aircraft weighing 40,000 pounds or more. Only after that did the British begin a program of laying concrete runways and increasing their length, which allowed the new bombers to take off safely even when overloaded. Interestingly, official documents of 1939 used different figures in the sections, normal conditions and heavy takeoff conditions. Only in the latter case could the bombers of that period carry their maximum bomb load or maximum fuel reserve. At the time the technical specifications for the new bombers were being written, an alternative solution to this problem, using catapults to launch aircraft, attracted serious attention. As early as 1931, a takeoff of a Vickers, Virginia, using equipment developed at the Royal Aircraft Establishment at Farnborough, was demonstrated at a Royal Air Force parade at Hendon. In that case, it was necessary to accelerate an aircraft weighing 18,000 pounds to a speed of 60 miles per hour over a distance of 300 feet. This was done by towing with a steel cable attached under the forward part of the fuselage. The winch was powered by compressed air. The system worked satisfactorily. However, the requirements for the bombers of 1936 were substantially different. It was necessary to accelerate 60,000 pounds to a speed of 110 miles per hour. At the Royal Aircraft Establishment, they designed a multi-row catapult based on experience with shipboard catapults for naval aviation. By 1939, the device was already being installed at the Harwell Air Base, but at that time, attention shifted to creating longer concrete runways, and the catapult was never completed. Interest in auxiliary systems to ease takeoff and to provide forced braking during landing for heavy bombers was revived early in the war, but for different reasons. As will be described later, Avro Manchester was tested with both types of systems, but this had nothing to do with the catapult launch envisaged in the original specification. The specification required that an aircraft with a load of 1,000 pounds have a range of 1,000 miles under normal conditions when taking off from a standard runway 1,500 feet long. When launched from a catapult, it should be able to carry 4,000 pounds of bombs for 3,000 miles, or 8,000 pounds for 2,000 miles. The machine was to carry 4 new armor-piercing bombs of 2,000 pounds each, the only target for which were considered large, heavily armored warships, or 16 standard high-explosive bombs of 250 or 500 pounds, or 2 18-inch torpedoes. The variety of bomb and fuel loading options greatly complicated the requirements. The specified flight characteristics included a cruising speed of 275 miles per hour at 66% of maximum power at normal weight, an operational ceiling of 28,000 feet, and a single engine ceiling of 10,000 feet. Armament consisted of nose and tail turrets with 2 and 4 machine guns of caliber 0.303 inch respectively, with a total ammunition load of 12,000 rounds. Crew accommodation was specified as 7 positions, although it was planned to take only 4 people: 2 pilots, a radio operator, and a tail gunner. It was assumed that the second pilot would also act as navigator, bomb aimer, and nose gunner. This proved to be an illusion. In practice, the Manchesters flew with a crew of 7, although an 8th position was added, the upper turret. When the Air Force Command determined that the new heavy bombers must necessarily have 4 engines, it was decided that another project would use a twin-engine configuration. In practice, this limited the choice of power plants to 3 options: the Bristol Centaurus, the Rolls-Royce Vulture, and the Napier Sabre. All of these engines were in the early stages of development, with the ultimate goal of reaching a power output of about 2,000 horsepower. The details of the technical requirements were handed over to selected aircraft manufacturers in the early summer of 1936, so that after receiving their proposals, 2 of the most promising prototypes could be chosen for production orders. Replies came from Avro, Bristol, Hawker, and a little later from Handley Page. Among the first 3, Avro's project quickly stood out as the most promising. This choice also had another advantage. Avro was not as heavily occupied with other aircraft development or mass production needed for the Air Force expansion as Bristol or Hawker were. It was soon decided to order 2 prototypes of the Avro 679, and on the 8th of September 1936, an official order was placed. About 4 months passed before a second design that met the specification requirements was chosen. This was the Handley Page HP-56. That aircraft was a development of the similar HP-55 model, which had been designed for a different requirement. However, it never appeared in the ordered form by January 1937 and evolved instead into the 4-engine HP-57 Halifax. Thus, the Avro 679 was destined to become the only twin-engine bomber built to that specification. Later, it too would evolve into the far more powerful Lancaster. In its original twin-engine form, the Avro bomber proved not particularly successful, mainly due to the engines. Aerodynamically and structurally, however, it was excellent, a quality later confirmed by the success of the Lancaster. The Avro engineers, led by Roy Chadwick, chose Rolls-Royce Vulture engines for the Avro 679. These were 24-cylinder X-shaped liquid-cooled engines, essentially made by combining 2 12-cylinder Peregrine engines, one mounted upright and the other inverted, sharing a common crankshaft. The engines were installed at the ends of the broad rectangular center section of the wing. The 2 main spars of this center section passed through the fuselage above the long bomb bay. The outer wing panels tapered along both leading and trailing edges and ended in rounded tips. The wingtips were slightly raised, forming a transverse V-shaped dihedral. The tail unit had twin fins and rudders with oval end plates at the tips of the horizontal stabilizer. The fuselage had a flattened oval cross-section above the main crew cockpit, where the two pilots, navigator, and radio operator sat. There was a small, raised glazed greenhouse. The entire structure was all metal, with flush riveting throughout the wing and semi-monocoque fuselage. Innovations included a powerful hydraulic system that operated the bomb bay doors, landing gear, flaps, and radiator shutters. While the designers were at the height of their activity and had already begun building prototype models, the Air Force Command was drawing up plans for the serial production of the Manchester, the official name for the Avro 679. By the end of 1937, Avro received an order for 200 bombers defined by the technical specifications. A year later, when the Royal Air Force expansion program envisioned producing 3,500 medium and heavy bombers by April 1942, this number included 1,500 Manchesters. To achieve such production volumes, it was planned to create the Manchester Production Group, which would include not only Avro but also Armstrong Whitworth, Fairey, and Metropolitan Vickers. In 1939, a new batch of 200 Manchesters was ordered from Avro and 100 from Metropolitan Vickers, which had a factory in Trafford Park. Final assembly and flight testing of the latter were planned at Avro's airfield in Woodford. Factories of Armstrong Whitworth in Coventry and Fairey in Manchester were also to be involved. Each of these companies received orders for 300 aircraft at the beginning of 1940, but these were soon canceled when it became clear that Avro's twin-engine bomber was unsatisfactory. The first of the two prototype Manchesters took to the air at Woodford on the 25th of July, 1939, with streamlined fairings on the nose and tail instead of the planned Fraser-Nash turrets. Flight tests soon revealed a lack of directional stability. To fix this, the fin area was increased by adding an additional surface to the fuselage behind the upper turret. The same tail assembly was installed on the second prototype, which made its first flight at Woodford on the 26th of May, 1940. This aircraft already featured a nose turret with 2 machine guns, a tail turret with 4, and a retractable lower Fraser-Nash turret with 2 .303-inch caliber guns. During further development, the central fin was enlarged and the lower turret was replaced with an upper, modernized Fraser-Nash turret with 2 guns. The fabric-covered ailerons and elevators replaced the previous metal-covered ones. New wing panels were installed, increasing the wingspan from about 80 feet to nearly 90 feet. In this form, by the summer of 1940, serial Manchester Mark I bombers began to appear at Woodford. The first of them was delivered on the 5th of August to the test center at Boscombe Down. Although the Manchester fully met the payload requirements, its flight performance turned out to be less impressive than expected. At normal weight, with Vulture II engines developing a maximum power of 1,700 horsepower at an altitude of about 15,000 feet, it could reach a speed of approximately 264 miles per hour. However, as mentioned earlier, the maximum bomb load or fuel reserve could only be carried during takeoff at an overload weight of about 50,000 pounds. Its cruising speed was around 205 miles per hour at an altitude of 15,000 feet. Nevertheless, pilots initially liked the Manchester for its handling and general flying qualities. The crews of the 207th Squadron, based at Waddington, the first unit scheduled to be re-equipped with the Avro bomber, placed high hopes on it. The second production Manchester joined the first at Boscombe Down in October 1940. By the end of that month, regular deliveries began from Woodford to special maintenance units at Shoebury Ness and Bryce Norton, where final adjustments were made before the aircraft were transferred to air bases. The 207th Squadron began receiving Manchester Mark I bombers in November. By the end of the year, 20 aircraft had flown out from Woodford, including one transferred to Rolls-Royce for work on improving the Vulture engines at Hucknall. Combat operations began during the night of February 24th to 25th, 1941. The 207th Squadron dispatched 6 Manchesters to bomb a Hipper-class cruiser in Brest. Each aircraft carried 12 armor-piercing bombs, each weighing 500 pounds. The raid was fairly successful, but one of the Manchesters suffered a hydraulic system failure and crashed during landing at Waddington. The hydraulic system, the most complex ever installed on a Royal Air Force aircraft at that time, turned out to be only one of the many persistent sources of malfunction that plagued the Manchester during its first months of service. The initial wave of enthusiasm that came with the arrival of the new bombers soon faded and was replaced by strong resentment among the crews. They constantly faced engine failures, propeller malfunctions, and poor controllability when fully loaded. Among all the problems, the most serious, of course, was the reliability of the Vulture engines. This engine had never been used before, was still in the earliest stages of refinement, and Rolls-Royce in 1940-41 was so heavily occupied with the development and production of Merlin engines that it could not devote much attention to the Vulture. Further deliveries of Manchesters in 1941 allowed other squadrons to convert to this type. The 97th in February, the 61st in June, and by the end of the year, the 83rd was also in the process of rearming from Hamptons to these aircraft. 3 more units, the 49th, 50th, and 106th Squadrons, received Manchester Mark I bombers at the beginning of 1942. Several aircraft were also transferred to the 144th Squadron of Coastal Command. However, from this moment on, efforts began to withdraw this type from combat service as quickly as possible. It had been repeatedly grounded due to the unreliability of the Vulture engines, and several squadrons temporarily reverted to using Hamptons. Fortunately, the arrival of the Halifax and Lancaster bombers rendered any further attempts to correct the Manchester's flaws unnecessary. Meanwhile, the production rate of aircraft continued to grow. The first machines from the Metropolitan Vickers assembly line appeared. The company had suffered a major setback on the night of December 23, 1940, when the first completed aircraft and another 12 in various stages of assembly were destroyed by German bombs. Actual deliveries began in September 1941. Tests of both alternative engine options were conducted in 1940 and 41. In case one of them entered serial production, the designation Manchester Mark II was reserved. However, neither of these engines proved much better than the Vulture, and a great deal of additional work would have been required to make them suitable for Royal Air Force service. Therefore, in 1940, Avro began developing the Manchester Mark III, a variant fitted with 4 Merlin engines. Retaining the fuselage, tail unit, and center wing section of the Manchester, the design featured new outer wing panels that increased the span by 12 feet, providing mounts for 2 additional engines. The calculated performance showed a significant improvement in flight characteristics compared with the Manchester. The project quickly received approval from the Air Staff, which authorized the construction of a prototype with 4 engines. The further evolution of the Manchester Mark III into the Lancaster belongs to an entirely different story, but it should be noted that its prototype took off on January 9, 1941, even before the Manchester Mark I had entered combat. The successful flight trials of the 4 Merlin bomber inevitably influenced the Royal Air Force's attitude toward the continued production and operation of the twin Vulture variant. By the end of 1940, it was decided to begin serial production of the Lancaster immediately after the first 300 Manchester aircraft were completed. However, in reality, the Avro and Metropolitan Vickers companies were instructed to end Manchester production earlier, after building the first 200 and 100 aircraft, respectively. Avro ultimately produced 159 Manchesters, including 2 prototypes. 1 aircraft was destroyed by fire before it was officially accepted. Of this number, the final 72 bombers were delivered as a modified version with a wider horizontal tailplane, enlarged vertical fin fairings, and no central fin. This tail configuration was first tested in flight on the second Lancaster prototype on the 13th of May, 1941, and was adopted as standard for serial Lancasters. Metrovic delivered 43 Manchesters, excluding those destroyed in the air raid of December 1940. Most of them, like the early Avro-built Manchesters, were later converted to the modified standard while in service. Some of the upgraded aircraft could also carry 2 bombs weighing 4,000 pounds each, and had a maximum takeoff weight of 54,000 pounds. Combat operations with the Manchester continued until mid-June 1942. In one of the last squadrons equipped with this bomber, the 50th, pilot officer Leslie Manser was posthumously awarded the Victoria Cross. On the night of the 30th of May 1942, during the first 1,000 bomber raid on Cologne, he carried a load of 1,260 incendiary bombs, each weighing 4 pounds. Suddenly, Manchester discovered that his Manchester could not climb above 7,000 feet, less than half its intended altitude. Nevertheless, he did not turn back but pressed on toward the target despite heavy anti-aircraft fire. The aircraft suffered severe damage. The pilot fought stubbornly, though hopelessly, to keep control and bring it home. Finally, he ordered his crew to bail out. There was no time left for him to follow. All 5 crew members survived. 1 was captured, while 4 returned with the help of Belgian resistance fighters. The last combat mission of the Manchester took place almost exactly a month later, on the night of the 25th to the 26th of June 1942 during the 3rd 1000 bomber raid, this time on Berlin. At that time, 2 Canadian squadrons serving within the Royal Air Force in the 408th and 420th were scheduled to re-equip with Manchesters and had even received several aircraft in May 1942, but the process was never completed. After being withdrawn from combat service, the Manchesters continued to operate in several bomber command training units until the end of 1943. Meanwhile, the first Manchester prototype was delivered in August 1940 to the Royal Aircraft Establishment in Farnborough. It was used there for developing systems to assist the takeoff of heavily loaded aircraft. Although the old idea of launching heavy bombers by catapult was rejected, engineers at the establishment considered using a rail-type takeoff track that would allow heavy aircraft to depart even in crosswind conditions. This was difficult when operating from concrete runways, whereas a grass airfield allowed takeoff in any direction. An experimental track was constructed at Farnborough, 4,400 feet long and 22.7 feet wide, matching the Manchester's landing gear track. The bomber's main wheels were placed on trolleys that ran along the rails. The aircraft was positioned for flight with its tail raised, using an L-shaped frame under the tail, whose ends rested on small auxiliary trolleys that followed behind the main ones. The idea was that the aircraft would accelerate under its own engines enough for its elevator to become effective. At that moment, the tail section of the aircraft would be released from the support and would hold in the required position until the aircraft reached takeoff speed. Then the pilot would be able to lower the tail slightly, and the main wheels would lift off from the trolleys on which they had been held by ordinary wedges. After that, the connections from the 4 trolleys and the tail support were to be returned to the starting position by means of a tug. In July 1941, such demonstration takeoffs were carried out first with a Hayford at a weight of 12,000 pounds, and then with a Manchester at a weight of 38,000 pounds. A variant was also considered in which the aircraft would be mounted on trolleys with the undercarriage being retracted into the fuselage. The possibility of attaching rocket boosters to the trolleys to ease takeoff was also studied. However, all of these schemes sharply reduced the number of aircraft that could take off in the same time. The whole project was closed shortly after the Manchester demonstration takeoff. In 1941, another problem arose. Bomber Command switched to night operations for its heavy bombers, and faced a rise in landing accidents. Heavy machines, often with combat damage, were landing in darkness at small airfields, especially when relatively inexperienced crews were at the controls. In response, the catapult section of the Royal Aircraft Establishment developed an airfield arresting device for landings. It could stop an aircraft weighing 60,000 pounds, moving at 70 miles per hour, at a deceleration of 0.5 times gravity. As with Stirling, Halifax, and Lancaster aircraft, an arrestor hook was also fitted to one Manchester. These arresting devices were installed at 20 aerodromes of Bomber Command. However, even an additional 100 pounds to the empty weight of a bomber was viewed negatively by the Bomber Command staff, and no aircraft were fitted with the arrestor hook for operational use.